a priority number, that you call it as integer. Priority number is always represented in the form integer. Integer is associated with each process. So for you have to assign a priority to each process. If you are using the priority scheduling algorithm, means first you have to assign the priority to each process. Next, the CPU is allocated to the process with highest priority. So first you have to assign the priority. Next, the CPU is allocated to the process with highest priority. So it takes the smallest integer as a highest priority. If 0 is there, it is a high. If 1 is there, it is a highest priority, like that. So the CPU is allocated to the process with highest priority. So here in priority scheduling, it may have the preemptive. It takes the preemptive scheduling, means it follows the preemptive schedulings. Whenever the priority process come, the CPU has to stop the current execution of the process and executes the priority request process. So that you call it as a preemptive. Next, it also schedules the non-preemptive also. The priority scheduling also works on non-preemptive. And the shortest job first is priority scheduling, but in reverse order, means it takes the smallest one first. The shortest job first is the priority scheduling, where priority in the inverse of predicate, next CPU burst time. And here in priority scheduling, you came across some problem. So what is the problem that you came across in priority scheduling? The main problem that you came across is the starvation. So this is a problem that you arises in this priority scheduling. What do you mean by this starvation? Starvation means, suppose when the low priority processes may never execute. Sometimes there is a chance to the low priority process never execute in the CPU. Means whenever, suppose the P1 is there, suppose suddenly the P2 came, the highest priority, it will execute and P1 has to be in wait state. Next, the P3 has came, which is the highest priority than P1. Next, P4 came. Like that, it is all the priority interrupts are coming, the priority process are coming. So the P1 has to wait until all the process that are executed by the CPU. So there is a chance that the P1 may never execute also. In some cases, the P1 never executed. So that you call it as a starvation. We are waiting eagerly, we are waiting hungrily. Okay, that is a starvation. The P1 has to wait until the CPU is given a permission to execute, given a chance to enter into the CPU. That you call it as a starvation. That problem may arises in the priority scheduling. Starvation means whenever there is a chance for the low priority process may never execute. And you can have a solution for this problem also. So what is the solution for this problem? The solution for this problem is aging. What do you mean by this aging? How this aging will overcome this starvation problem? Aging means as time progress, if you take the time progresses, increases the priority of the process. The priority of process. So means here you are assigning some time to each process in the according to the priorities. Suppose so there is a chance to execute the low priority also. Means whenever the time is over, the processor has to execute that process, even though you are getting the highest priority request. So that is the aging. So that is a solution for the starvation. The solution for starvation is the aging. Now let us see the example for this. Example for this priority scheduling. Let us take the process time. Process Let's take P1, P2, P3, P4, P5. Total 5 process I am taking, and the burst times for that process are, let us take 10, 1, 2, 1, 5. Okay, 10, 1, 2, 1, 5. And you have to take the priorities also. I said already, whenever you are introducing the process, you have to assign the priorities. Then the CPU will take the highest priority process. The priorities is 3, 1, 4, 5, 2. So these are the priorities. Now let us see how the process are executing in the CPU. So the first, which is having the highest priority? I said the priority will start from small integer. The 1 is having the highest priority. So P2 is highest priority. First P2. So what is the burst time of the P2? Only 1. So next highest priority is P5. So what is the burst time of P5? 5. So 1 plus 5, 6. Next is 3. That is it. P1. P1 burst time is 10. So you will get 16. 10 plus 6, 16. Next is P3. P3 is having the next priority. The burst time is 2. 16 plus 2, 18. The last is P4. The P4 burst time is 1. 18 plus 1, 19. So this is how you are going to be, the CPU is going to be calculated. Means take the processes. And what is the average time of this thing? Average wait